This conference will now be recorded.
Hi everyone, let's start the session. So last session we discussed about the what is exactly big data and big data Hadoop technologies, what are there and what are the challenges with them, and finally people why they are going for like what Spark. So that is what I have covered in the last session. Maybe if someone has missed that session, you can just go through the last session recording now. And today I want to take it like what more interactive first. So if you have any questions, otherwise like what. So how exactly if you want to explore the Spark now, what are the things we need to keep in your mind? And we'll go with like what some practical use cases now. So that's what the plan of the session now. Okay, before I do that one, so any specific questions anyone have it regarding the Spark point of view, you have it in mind, let me know. I'll answer it now. Any kind of doubts. You can unmute yourself and you can. Okay, fine then. So if you don't have any questions, then let me continue what I want to cover today now. So the first primary thing is like what people who want to explore on the Spark programming languages wise, like what, as I said, there are four programming languages primarily is available now: Java, Scala, Python, R. And coming to this, the mother language of the Spark is like what? It is a Scala. And first, you should have at least the basic idea on like what Scala should be there now. So that is what we will be going to starting on the initial classes now. Okay. So this today's session is not the intention of to start the Scala now, just to get a little bit deeper knowledge on like what we are focusing on this course. That's the way I'm going here now. Okay. So we should understand like what first thing is Scala now, because if there is a code already is available, you want to understand now. So at least that much knowledge you need to have it now. So, but how the Scala is implemented is it is based on the Java. It is based on the Java. Now the question comes here is like what? Why Spark is chosen Scala? Why not Java or Python or other programming languages now? Okay, let me clarify that point today now. So the history of the Spark we are talking about is like what? In 2008, the Mesos project is started in 2008. The history of the Spark when we see like what? In 2008, the Mesos project started by the UC Berkeley University, some of the students now. So what is the main purpose of this Mesos is like what? Resource management. So this is as same as like what we are using nowadays, like what yarn. But yarn is started in 2009. So before yarn only, we also have a resource management concept in Hadoop, that is what called as a MapReduce. In older version of the MapReduce used to do two things now. One is data processing and second one is resource management. That is a confusion part from the initial version of the Hadoop now. But later, so whatever the resource management part is there, like what they completely get rid of from the MapReduce now, and they said MapReduce is only meant for processing and yarn is for resource management, when yarn is like what developer now. Before that, so MapReduce itself is used to do like what processing as well as resource management. So at the time of 2008, when the people this Mesos people are implementing like what they know, so what is exactly limitation of the map reduce, exactly the resource management aspect. Okay, and also they are very clear at that time is they don't want to develop this project on Java. they want to develop on like what at that particular time, at the time of 2008, the booming programming language is like what Scala. So what is exactly reason is in 2002, in 2002 this Scala is started as a in-house project now. In 2002 Scala is started as a in-house project, and one of the main implementer of the Java generics. I don't know how many of them having idea on the Java. In Java, there is a concept called generics now. Okay, so that generic concept like what implemented by Martin Wodesky. So one of the implementer in that. So he is exactly thinking about. So Java is good, but it is lacking some of the features now. Okay, so not only Martin Wodesky, there are some other people also think like that. There are so many alternative programming languages are came on top of the Java some things and parallel to Java also. Okay, so in that right now very famous programming languages are like what, one is Scala, second one is like what, Groovy. Maybe some people might be here this also. There is one more programming language called Groovy exactly. So these two programming languages are like what on top of the Java, very famous now. Okay, they build on top of the Java only. Only reason behind that why they build like what, they feel some of the features in Java is not good. So same thing is like what Martin Odesky also thought that, and he started in his team like what as a in-house project in 2002. Around 2004, around 2004 like what he released the first version of the Scala, and people started using them, and they feel the some of the features like what Scala is giving like what it more useful, and also like what more concise code comparatively Java now. Okay, so that is the first primary reason like what why people shifted from like what Java to Scala. And one more advantage of the Scala is whatever the Java features you have it, whatever the Java features you have it, all the features are available in Scala. Extra, you have Scala features now. That's the reason they are going with the Scala now. Okay, and here this Bezos people also why they didn't went with the Java is like what, if you go with Scala, they're getting all Java features. Along with that, whatever Scala is providing also, those features also it is providing. That's the primary reason like what why they started this project with Scala now. So then after that, they just continued, as I said yesterday only, they just continued now, and they build the solution, they want to test it at that particular time like whatever the programming language they use here now, same programming language wise. So they have started building the testing project for mesos, that is what exactly Spark. And why I'm saying mother language of Spark is Scala is like what, the main reason is like what at that particular time, which is the famous programming language like what Scala. The reason is Scala supports the object oriented programming language, like whatever the complete Java features are there, it supports. Along with that, it is also having one more inbuilt feature is like what, functional oriented. In Spark, mainly you will be going to see on a functional style, functional programming part is like what mainly you will be seeing it now. Okay, so that's the reason like what you should aware of like what difference between these two now. But coding aspect and those things I will cover as part of the Scala now. What is functional oriented programming, object oriented programming now, I'll cover that in detail with like what in Scala session now. But I'm just giving an idea why we should go for Scala. The main reason is like what, it supports two variations now. One is object oriented, second one is like what, functional oriented. When it comes to the big data world, like what, these two are important. In older days, it is not like this. In older days, we used to have only functional oriented programming languages and only object oriented programming language now. But nowadays is not like this. You pick any programming language today, they provide always these two now. If you take the latest version of the Java, also not only latest version, last few versions of the Java, they are already supporting like what this functional oriented style in that. And if you take the Python, also like what it supports like what object oriented as well as like what functional oriented. Now almost all programming language nowadays what are available now, they support both object oriented, functional oriented now. Okay, why? Because is functional oriented, the main goal is like what, instead of building your logical functions like a what, okay, so there will be predefined functions, statistical functions, mathematical functions, like what people build it, is like an underlying system. Now they ask you to use it, that's one of the main thing. And also it follows the, in mathematics there is a functional programming. Maybe in engineering classes you might be here like functional programming, like what in mathematics there's a functional programming concept will be there now. It follows like what certain standards there, also the functional programming languages also follow those things along with like what the building some existing functions, and they also follow like what certain functional programming standards now. So that's what exactly as a high level I can say it for today now. We'll take it little deeper in the later point of view. Okay, so is that everyone is clear? First of all, why Spark is chosen, Scala is the mother language? Any question on that area? Okay, good. Now the next part is now, okay, so they started implementing on like what Scala, as I already said. Now if it is Scala means Java support is already inbuilt. Now we don't need to talk about Java and Scala like what, same only. Okay, just a Scala is on top of the Java. The Spark supporting Scala means like what, it obviously supports like what Java, so we don't need to separate those things now. What exactly extra it is supporting is like what, one more is Python, and other one is like what, R. So coming to this Python and R, initial versions of the Spark. Okay, in interview point of view, these statements will be going to help it. Please keep in mind. Okay, so in initial versions of the Spark, like what, Spark forced to use only Scala only. If you want to get a better performance from the Spark, is like what, it force it to say like what, use Scala, I will give you the better performance. But if you are going with the Python or R, like what, I won't give you better performance. This is a clear cut statement from the Spark. In Spark 1.x version, primarily 0.x and 1.x version, like what, so Spark clearly said like what, I can't give you the better performance by going with the Python and R. The reason is why exactly is like what, Spark is not implemented on the Python and R. It's implemented on only Java and Scala now. Okay, and if you are executing in a Python code, so what is a challenge for them? Like what, they started supporting Python, but how exactly they support here is like what, whatever the Python code they have implemented, that is just to interact with actual Python what you written only. Okay, Spark is not really executing the Python code. There is a concept called like what, py4j. There's a concept called py4j. Py4j library will be there now. What is this py4j library? Means you can execute your Python code through Java. Through Java. Py4j. Py4. 4 means for, generally people will use for, 4j is a for Java like this. Okay, py4j concept is there. No, that library, if suppose some logic you have written in Python and you want to call that logic in Java, is like what, you can able to, if you use this py4j library, you can. What Spark exactly using here, like what, py4j library. Using this py4j library, like what, whatever the Spark code you written in a Python, they are calling through Java exactly. That's what they are doing. So this call generally like what, cross programming languages are like what, always costly call. You have to avoid it. Okay, so if one programming language you're calling other programming language, like what, generally these are costly calls now. It will take time also. So that's the reason people will not prefer now. Performance aspect, you want to get it like what? People won't prefer this now. Okay, one of the same challenge if you go with the database also. I don't know how many are aware of this one. No, performance aspect when it is coming like what? Most of the database systems like what? They use it to write in a C++. But nowadays, people are implementing the database languages in a Java, Scala, Python, like these things also they're implementing now. But actually, if you want to get a better performance from like what any programming language or any database system like what good to write in like what C++ now. If you write the things in a C++, those will do native calls exactly. Those native calls are like what very faster response they will give it now. Okay, so when we go with like what one programming language to other programming language like what to get the performance like what people will has to compromise on some extent now. So that is the one challenge now. That problem is there in Spark 0.x version 1.x version, and later they realize it now. Later they realize it like what? So this is not good for the future of the Spark now. If you go like this, people may not use, the people who are from like what data science world and data analytics world who are there like what, they won't start using the Spark now. Why? Because you are forcing to learn Scala. Spark is clearly saying, do you want to get a better performance? You need to force to learn like what? Scalar. So that is the initial statement. Nowadays is not. Okay. When coming to Spark 2, what is exactly the statement they clearly come up with like what? Unified programming language. Okay, Spark come up with the concept is like what? Unified approach, completely unified approach. Now what is this unified approach is like what? Two scenarios. No, one is coding aspect wise like what? Choose as you wish which programming language you want, choose as you wish. I will give you the same performance. That is from Spark 2. In Spark 1 you don't have like that. Okay, and the second thing is whatever the functions, yesterday also I mentioned now. Okay, so there are some functions we used it also, generally we call it as a operations. So these operations are like what? Across the programming language now. Across the programming language like what? They are same. That is the unified approach like what Spark 2 is started. So they reach some extent, no, but not 100%, but it is better than the Spark 1. Okay, so Spark 1 to Spark 2, one of the main difference is like what? Almost Spark 2 is around 20 times faster than the Spark 1. Almost 20 times. The performance like what? That much drastically improved from Spark 1 to Spark 2. That's the reason they took more time to release the Spark 2 also. They took so much time exactly to release the Spark because there are so many major features like what they introduced. One of the main feature is like what I'm discussing is like what? Unified approach now. So which programming language you want to use it, up to you. I will give you the same performance. So how exactly it supports that? So that is what we will be going to talk about as part of the Spark SQL. I'll just give an idea for today now, but how exactly that concept they implemented like what? Using the concept of Spark SQL. So in one of the library in Spark like what? Spark SQL now. In that Spark SQL, they have a concept of data frame, data set, data frame, data set. So using this data frame concept now, using this data frame concept like what? They come up with this unified approach now. Whatever I'm saying it like what? This unified approach, they come up with the data frame. If we are going with the data frame approach or data set now, so the difference between these two is like what? Data set is an enhanced version of the data frame now. Okay, so if you go with this data frame or data set approach like what, doesn't matter which programming language you choose now. Okay, what they do like what, they understand all the code whatever you written in any programming language was you written, they will translate into a in a single format. That's the reason like what they introduce the same performance now, just like a translator. Okay, so if I'm speaking in Telugu, like what, there is a translator is there, he can translate to like what, English. If I'm speaking in Tamil, like what, the translator can translate to like what, English. If I'm speaking in Hindi, he can. So there are different languages we have it now, but the translator responsibility is what, translate to what other system can understand now. Like that exactly they introduce the data frame concept now. What this data frame is do, like what, you write code in Java or Scala or Python or SQL, doesn't matter. It will translate into a byte code which can execute by the underlying Spark system. Now it will translate into that, it is executing. That's the change they introduced in the Spark 2 now. Okay, but in Spark 1, that feature is in a development state now. They are not, but in Spark 2, they release it now. And on that feature only, some of the major improvements they did in the Spark 3 now. Currently, what industry using Spark 3 is like what, so more enhanced features, whatever the gaps in that implementation wise, like whatever it is there, they implemented. And also Spark 3 mainly targeted on which area is all the libraries. Spark SQL, utilizing Spark SQL features in the streaming concept, mlib concept, graphics. What are the three libraries we have it, like what, in all the three libraries, like what, so they want to build the features using SQL approach only. They want to build the features in a SQL approach only. That is the place like what Spark 3 targeted. No, some extent it is did in the streaming and mlib, but graphics is not it. Okay, so graphics point of view, there is a third party libraries people are working on right now, mostly in Spark 4. It will come into the picture now. So that's the history going on, and performance aspect wise and futuristic aspect wise, like what is happening, performance, all these things, which programming language I want to use it, that statement, like what, nowadays doesn't matter. That's what only I explained in yesterday's session also. Learning point of view, you don't see any difference. Performance aspect also, you don't see any difference. Only one difference you will see between these programming languages, like what, that is, if you want to build any custom feature which is not there right now in Spark now, okay, you want to add that feature, then you have to do coding in only Scala. Otherwise, you are good to use any programming language by going with the Spark SQL. Is all are clear till this statement now? Any questions on this? Might be explained little lengthy, but still the concept, if you're clear, I'm good. Otherwise, you can ask me the question on that. Okay, can quickly someone summarize these points now, just to understand how much you are able to digest that? At least one point from everyone. Yes, whatever I explained is like what, just interview point of view only explain now. Okay, why it is this? Can I use this or not? If suppose someone asks like what, which programming language is better to use Spark? You should have an answer by discussion now. Can someone tell me which programming language is best to use Spark?
It's like Scala and Python.
Why? That's not what I conveyed.
For Spark 1, we should use Scala, but for Spark
Yes.
2, they can we can use any language. Spark will give the
Yes.
same performance.
Yes. So from Spark 2 onwards, we have a concept of data frame and data set. Now, by utilizing that, any programming language you use also, same performance will come. Only when we go for customizations, then you need to go for which programming language?
Scala.
Scalar. So
One
that is
skill
the
up.
way you have to convey to the answer. No, that's way the interviewer won't ask next question on that. So always we have to prepare our answer like what interviewer should not ask next question on that question now. Okay. Yeah. Something else someone is saying. Okay. Good. So the next one is like what Spark 1 and Spark 2 if you compare. So which one is faster and how many times it is faster?
2 is faster 20 times.
Yes. Okay. So one reason I explained for you like what that is a data frame data set concept now. But as part of our performance class now, I'll explain there are some more concepts are there now. So but it is almost 20 times faster than that. Okay. And one more thing people will generally they all knows this one now. Let me show you through Spark website once. Let me go to a Spark website. Okay, so this is what I'm talking about. In older version of the Spark you don't see this keyword now, unified keyword. Okay, so what I want to explain here is they change the design. Okay, so they use it to show different landing page in the older versions now. There generally one question will be there. That's what I thought of showing it. They get rid of that. Mhm. Let me see. Is it possible to get it from here? Yeah. So they just get rid of that part actually. Okay. So that's reason is like what this data frame concept, whatever I'm saying it now. Okay. Fine. We'll come that point. Just let me give an idea on that question now. Some people might ask this question now. In yesterday also explained in a sub part of that one. Let me take the question. So how many times like what Spark is faster than MapReduce? Maybe some people might hear this one, may have an answer also. Okay, but I want to give little more explanation on that now. Can anyone have an answer for that? How many times Spark is faster than Hadoop MapReduce?
100 times faster.
100 times faster. Okay, what about others? That information used to show it in a Spark website in older website. No, and I say like what older versions wise, they get rid of that part because of like what Spark now completely turned to SQL. As I said now in Spark 3, their main features are turned to SQL approach now. So the documentation they changed it now. Okay. So the answer for this question is please clearly understand here. Spark supports mainly three variations now. The way of execution wise, three variations it supports now. One is it can execute utilizing the disk. That is what called as a disk level processing. Spark can execute the things utilizing the disk like a MapReduce approach now, disk level processing. Spark can also supports by utilizing the in-memory. That is what like what in-memory computation now. It can also execute in a in-memory approach. This is the second variation. Now the third variation. The third variation is like what combination of disk and in-memory. Combination of disk and in-memory. So when we are answering this question like what with this three variation ways, you have to think and answer exactly. So whatever the answer he said 100, the answer is like what based on in-memory computation. So that is not possible if I go with the disk level now. Okay, so that's the reason how exactly the answer here is like what Spark and MapReduce when you compare it is like what it is between 10 to 100 exactly. Nowadays like what it is around 112 or 130 percentage faster exactly between 10 to 100 you can say it now exactly. If you say it like 110 also, okay, between 10 to 110. So why we are saying between exactly answer is like what if we are utilizing the only disk level processing like a map reduce now, it is still faster, but how many times faster like what approximately like what 10 times, approximately 10 times faster now. But if you are using the completely in memory now, that is around 110 times faster now. It's not exactly around 110 times, but you cannot process everything using Spark like a word 100% in memory. That is a place only people will think wrongly exactly. Okay, so please be very clear on this. Depends on the volume of the data, depends on the volume of the data, and also like what your environment having how much memory is there. Depends on these two combinations like what your performance will be like what between 10 to 110 now. It may be 80 times, it may be 90 times, it may be 50 times or 30 times. Depends on how much RAM you have it and how much disk space you have it now. Based on these two it will happen now. So it is not always 100, it is not always 10, it can be in between also. Is that answer is clear now? The way of answering also is all are clear that point now. So can you please quickly summarize someone now? So how many times Spark is faster than MapReduce? What is the way to answer now?
Based on the memory size and based on the data size, it will
Yes,
vary from 10 to 100.
yes. Okay, approx. Use the on value key. Valid keyword
Yeah,
is
yeah,
approximate. Okay,
approximately.
approximately between 100 10 to 100. That is because exactly we cannot say it also, because that will be like what depends on system to system will happen. Whatever the answer we convey, that is always people should not question on that. Okay, that is a way try to convey it and just preparing your mind how you should able to answer. That's what the intention to ask. Okay, so because like this so many things we have to discuss in our course now. Okay, when we are going for Spark like what every line when we execute also these type of some questions will be there now. So how I am saying it now, please think in that way to answer it now. So that is the will give you, because this knowledge what I am saying is by expectation will come. By reading a book it may not be, sometimes by expectation. Okay, simply I cannot say 100. So how you need to by doing some exercises by observation it will come. So those type of statements I'm giving it now, please always keep in your mind. Hope you all good on this statement till this point. Okay, now come to the next part is like what operations. As I said like what Spark supports like what two type of operation. Not only Spark exactly, any programming language, generally any programming language, if you want to do some aggregate operations, if you want to do some aggregate operations, we cannot be done with like what one operation now. Okay, just a second. Okay. Yeah, 1 second. Your video was getting like poor connection. So what do you mean by that? Is it anyone facing this issue? Am I properly audible?
Yeah.
I'm not sharing any other screen, correct? Just one page only I've shared. What is mean by poor connection? Then is I didn't understand. Is it for everyone means then it is a problem from my end. If it is for
No,
only,
you're audible.
yeah, it could be network issue because we are in remote location now. Things might happen. Sometimes can be in my side also, but just okay. Yeah, fine. So hope everyone is good. Let's, if not, just you can also ask the question. I can repeat it, but make sure that like what. So your network also like what in a good state now. So now what is the one more point I'm discussing here is like what operations in any programming language. Generally in any programming language, if we are going with like what some aggregate operations. So in that case, like what there will be two type of variations will be there. Okay, so it cannot be done with like what single operation. Same thing in Spark also. In Spark also like what they have two operations, and these two operations they adopted from like what Scala, from Scala programming language. They adopted not only in Scala, Python or other programming language also this concept is there. What are those two operations are? One is called as a transformation, second one is called as a action. There are two operations like what they are going. One is called as a transformation, second one is called as a action. In a simple example, let's understand that. So take an example of I have a list. So something list of 1, 2, 3, 4, 5, 6. I'm not going with any programming language syntax here. General I'm saying it now. Okay. So there is a list is there and some list of numbers are there. So what is exactly transformation? Maybe in your school days, like what if you remember functions concept now. One to one, one to many to many, many to one. So these are the functions. In functional programming, mainly they use these type of things to solve some of the problems now. One to one, one to many. You will see in Spark also these things now. Many to one, many to many. When we are learning our operations like what they fall under one of this, maybe it can be one to one or one to many to one, many to many also one of this they fall under now. Okay, so if we are going with like what one to one or like what one to many, one to one or one to many or many to many. So all these are comes under like what transformations. What is action concept is like what mainly this use case. Many to one. Many to one use case is like what mainly as an action now. Okay, let me explain with an example. F of x equal to x plus 1. F of x is equal to x plus 1 for each x. Okay, in list. So in generally in a mathematics like what you will write for all x belongs to some a is a set like that, correct? So I cannot write in notepad like this. I'm just putting in a normal syntax. F of x is equal to x plus 1. So now suppose if you do f of list, okay, so for every element in this list, it need to apply this logic. Now x is equal to 1, then 1 plus 1 will be coming 2, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1. So what is exactly I got here is my f of list is this one. Okay, so now can you tell me which one comes under this out of these four, like what, which is exactly going here? What is this function comes under? One to one or one to many to one, many to many?
One too many.
One to one. It is coming under one to one. You have taken one value, you are giving back as a one value. So you taken one here, translated to 2. You taken 2 here, translated to 3. Okay. Suppose there is another example now. F of x is equal to x only here. X is okay. There could be a function you can write like this. Okay, which can give only even numbers or which can give only odd numbers only. So now if you have implemented this function, then what is exactly output will come here is 1, 3, 5. Okay, so here also it is also comes under 1 to 1 only, but for every one it is trying to give 1, but there is also some cases like what 1 to 0 also possible. So those are called as a filter operations. Those are called as a filter operation. So now here whatever our input data is there, it is filtered here. There are some of the records are like what filter, it is comes under 1 to 1 only, but there are some records it can goes to 0 also, 1 to 1 or 1 to 0 also. This both are like what similar case only, they call it as a, this is filter. And now there is a one more function you might be implemented. F of x is equal to y, sum all the values. Okay, so in this case like what f of list, I'll be going to get the answer is 21. If I sum all these numbers now, if I sum all these numbers, I'll be getting it as a 21. So this case is this one, many to one. You have input having 6 records, but you got output as only 1. Okay, so this use case can be applicable to min, max, or count, anything. So what is exactly this sum, min, max, count? These are called as a actions. These are called as a actions. So what is this actions? Generally they go into the scenario of many to one. Now intention is clear here now. So 1 to 1 and many to 1. So these are the two common variations like what mostly you see, but in some cases like what 1 to many also you see, many to many also, depends on the use case. Now some aggregate operations when you're trying it like what, sometimes you might do group by also. This is right now I'm talking about all the values now. Okay, maybe some only like what even number wise, some only odd number wise. Okay, or some maybe some specific group wise, count some specific group wise. Okay, you are asking like what some grouping condition there, exactly like what this many to many case is going to come now. Okay, input having a 10 records, your output will be going to come maybe like what 5 records by doing a grouping logic also. It depends on requirement to requirement, it happens. So the functional programming languages are like what mainly utilize like what their function implementations on one to one, one to many, many to many, many to one, and some cases are like what the end can be also a zero. Those are called as a filter cases now. Okay, so in Spark primarily whatever we are learning these things, these are like what fall under like what some of them. So I was not explain what is these things, this is what our actual course will answer. Okay, so this flat map comes under like what one to many, just I'm giving an idea, not going more deeper. So map will come under like what one to one. This reduced by key come under like what many to one. Okay, there are three things here like what it's fall under these three cases. So there is also a group by that will come under like what many to many. So whatever these operations we are learning is like what these operations follow under like what this. So that's what that knowledge mainly we have to build it now. Hope you all understand what is exactly functions and main operations what they are talking about now. Okay, any use case you want to solve it like what these operations like what we have it now in Spark, you just need to understand, you have to imagine that okay your problem can solve with this means what are the operations are with there with that, take that one and try to apply it. That is the way you will be solving your problem in Spark. Always you have to build the knowledge on like what these operations now, these all four operations you have to keep in your mind. There are more than 100 operations are there, every operations we'll be going to learn and we will be going to practice it also. Just a second. Okay, these are the operation, all these operations, I'm not saying one operation, all these operations we have to learn. That's the goal of like what learning the Spark. If you learn all this operation, any problem you can able to solve with the Spark. Hope you all clear on that point. Any question on this? Okay, yeah. So if you have any questions, let me know. Otherwise, I'll just hold it here for today's session. I don't want to take the first 2 3 classes like what long. And once we are starting like what the Scala actual session, no. So from there onwards, like what in your system also you have to configure and you need to do it now. So then I'll be going to slowly take the session like what 1.5 hours now. First 1 or 2 classes like what I just want to you have to familiar with the terminology. I'll go with 1 hour session. Then later I will take it like what 1.5 hour session now. Okay. If you have any questions for today, let me know. Otherwise, I'll just hold it for today here. And I could see the people having some network issue. So is Raj, you're not able to connect it. I can able to see clearly in my screen now. And same thing for like what the other one also like what Dinesh. So they are having some issue with your network point of view. So you need to just work out from your side. Okay, people, I could see in my screen like what if their voice is in a cross mark means they are not able to connect their audio. So I could see for your name exactly. That means there is a network connectivity issue. Those people I'll recommend rejoin it. When you rejoin it, there is a chance of like what it can connect also. Yeah. Is all are good? Any questions? If not, I can hold it for today here. Okay. Thanks. Thanks for everyone.